Hi, welcome to this Open Security Summit in June 2023. And we have André, one of our heavyweights in application security, expanding on his thoughts on, actually a very interesting area of security, which is the web applications language negotiation. And he's going to give us a bit of a run through on where we are. And then, we're talking about maybe doing a panel in one of the next summits, but this is a great introduction of this, quite interesting topic that, it was mentioned that there's some interesting ways to exploit it. So, André, over to you.
Cheers. Definitely heavyweight. That's a good one. I'm actually quite heavy at the moment.
Well, that was a compliment.
It's pretty accurate. Thank you for that. So I'll start. So if you ever wondered why you get bombarded by a particular type of advertisement when in your own language, when you're browsing the World Wide Web, or if you're just curious of how websites function in different languages, or you just want to understand a bit better what happens and what are the consequences of specifying your language preferences, this talk might be for you, and I will only require that you have used the internet before, or more specifically the World Wide Web. And since you're probably seeing this online later, if you're not here, that will be, you will qualify. And I hope you find it interesting. So during the pandemic, me and the wife, we were living in a north-facing apartment in London, in Dublin, actually, sorry. And we passed a lot of our time watching TV series. And being that we are from opposite edges of Europe, we communicate mostly in English, despite the fact that we manage quite a bunch of different languages altogether. I manage to speak Portuguese, English, French, and Spanish. And she speaks Lithuanian, Russian, English, and she understands a bit of Spanish as well. But regarding what we can watch together, we are somewhat restricted to English. So one of the shows that we used to watch was called A Place in the Sun. And if you're not familiar with it, it's one of those shows that people from the UK and Ireland buy properties in southern countries, apartments and houses. And that kept us entertained during the pandemic. Now, influenced somehow by the show and due to some other more pressing needs, we did some financial exercises and gymnastics, and we figured out a way for a move from Ireland. And it was supposed to be temporarily, but we did have the aim of making it a bit more permanent. So last year we moved to Spain. And me being from Portugal and having a similar skin tone as the Spanish, and a large forehead, sometimes the local people talk to me in their language. And I've just lost my train of thought. They speak to me in their language, and mostly I understand what they are saying, and I feel very comfort when that happens because it means that I actually fit in, I don't stand out. But when it's my turn to respond, I have to negotiate back that conversation into Castellano. So in Spain, you might have this perspective that everybody speaks Spanish, but in reality, they speak Basque, they speak Catalan, they speak Valencian and other languages, and Castellano is what we know as Spanish. And this negotiation is not very different from what happens on the World Wide Web. And although there are many different ways of serving different languages, in this talk, I'm going to focus on the HTTP way in the proactive language negotiation. And let me kick in. If I can change the slide, which I'm not able to. Oh, no, it just takes a bit. So my name is André Ferreira, and I hold a master's degree in information security from Northumbria University in the UK. And I've worked in the IT space for more than 2 decades for small and large companies. I've worked in different markets, I've worked in different countries, and if you need a trustworthy person that can give you a hand, I'm currently available. A cool thing about me is that my name is common, and I share it with many other individuals, and we all have an accent, an acute accent on the E. And the slides take a little bit to pass.
Yeah, there you go. We got it.
Fair enough? Okay,
Yep.
cool.
Yep.
So when we think of something that we want to share, be it words, spoken or written, or gestures, those are symbols for ideas, emotions, or information that we want to transmit. And when we want to make our messages understood, preferably the way that we thought about it, we need to have some rules. We need to follow some rules. Now, this communication process must follow also a protocol. When a person talks, the other one listens, and the communication has to be done in a language known to both, and preferably pre-negotiated. To avoid situations like parlez-vous français, comprends pas, habla espanhol, no, e português fala, também não. Or, and this one is going to sound funny, Artu calvi dia tu viscai, taip, pascambincius monai, which will be something like, do you speak Lithuanian? Yes, let me call the wife, because it's a language that it's very hard for me to learn. Now, in early life, we also learned that words are made up of individual letters, and those two are part of the overall protocol that we required in order to communicate. So communication shouldn't still be thought about having two radios playing music at each other, because there's no communication taking place. Communication needs to be thought as the successful exchange of information. And perhaps it will surprise you, but there's 8,324 spoken languages and sign languages that are currently documented. And in the planet, we have 7,000 of those languages currently in use. And with all those languages, having a universal translator could save us from having to know that many languages. And we know that from sci-fi, this will work great when we have to communicate with aliens, as to try to defend ourselves from something stupid that we're going to do. However, there are some devices that already exist to help us with this. When I was preparing for this talk, I've stumbled across, and this is still a bit slow, Vasco, which is a device from a company based in Barcelona, Spain, and the reviews in Amazon are actually quite encouraging. I have no affiliation with the company. And if you watch recently Google I/O, you also saw a person being translated in real time from English to Spanish with their lips matching what was being said. So the future advancements in this area look quite promising. And that is until, of course, we meet somebody like Arturis or have our own C3PO. Because then things will get much more interesting, I think. Now, language is not only about conveying meaning. There's an associated culture and a diverse history behind it, and details matter. And as an example, you might have already learned this, but the Portuguese words muito obrigado do not actually translate to thank you, although it can. But historically, from Latin, it would be more closer to I recognize an obligation to return a favor to you in the future. Muito agradecido, on the other hand, would be closer to thank you. And this cultural juices, along with slang and the detestable acronyms and abbreviations, are all part of an identity that translations need to accurately represent, which basically makes us think that sometimes we need to have subtitles for some things that will be translated. And diving super fast into history, computer history, with long jumps, from the time when an American professor ran a wire across campus, electrified it, and used it to ring a bell at the far end of campus, to the invention of Morse code as a way to transmit information fast and at far distances, from mechanical typewriters and teleprinters that were later adapted to mainframe computers, to the creation of Request for Commons 20, US ASCII, humans have invented and discovered a lot in the last 200 years. And focusing particularly on US ASCII, which has 7 bits that allow the representation of 128 code points, being that the first 32 are control codes that you will use for controlling devices, all devices, and also for magnetic tapes. And all of the other codes from that being the alphabet and numbers and punctuation, humans have discovered a way to use on and off, or 1 and zeros, to represent language. Now, US ASCII has been a great American invention, but very pragmatic towards their particular needs and very insufficient when it comes to represent more than 8,000 languages. For example, if we grab my name, it can't actually be accurately described in US ASCII because of the lack of the acute accent on the E. And the way that this basically works is if you look at this table 1, from the first row where you have 64, 32, 16, and so on, you have a stream of bytes, so you have like 7 bytes, and if it's a 1, you'll add the value that is on the top, and when you sum them all together with the bytes that you have on your right, that will give you a number, 65, 110, 120. And that can then map to a character to be displayed on the screen. I stress again that US ASCII is not 8 bits, it's not an octet, it's 7 bits. And perhaps I could forgive the Spanish department responsible for issuing my driver's license. However, it's the second time that it comes wrong, because the first time they got the surnames order wrong, but my first name was right. It had the acute E there, but this time around they came with the order right, but it's missing the E.
So Andrea, at least you didn't got like a SQL error or or you didn't got a call and said, hey man, why did you just crash half my database?
Yeah, the first error was actually quite interesting because in Portugal we have first the surname of our mother and then our father, and in Spain they have it the other way around. So when it came, you know, I had to correct it because I have other documents that need to match exactly the same order. But this one, when I saw it, I just had to laugh because I thought it was really funny. Now, because US ASCII is limited, and to be able to represent other languages, US ASCII got extended throughout the years. Other car sets were developed, and we have examples here of what they are. But it got to a point that it was really complex because different manufacturers had their own thing, and when they needed to translate from one car set to another, it was messy. And this is where Unicode came in. And Unicode allows you to map 150,000 characters, more or less. Not so many, but almost 150,000, which is way more than 128. And it's really pretty smart also because you can represent most characters, well, some characters with only 8 bits, but if you need more, then you can have 16, and then if you need more, you can have 32. So it's a variable length car set. Now, when you buy a new computer, it should ask you to specify the language that you want to use it in, unless somebody else has already done that for you. And the operating system language will allow you to interact better with the device. And if that device comes already, the computer comes with, or even if it's a MOA, comes with a default browser installed, it will probably be following the language of the operating system. And if you go to the internet then, if you connect that device to the internet, and you go to a page and you want to download another browser, you'll probably see that web page on the same language as you have on your computer. And let's imagine that that page would be this source code, this little bit of source code that I have on the right would represent a bit of the HTML that that web page gives back to you. So I want you to observe that there's a little piece of text that identifies lang equals eng, which is the abbreviation for English, and that page is actually with a car set equal to UTF-8. So a trick question here would be, do we really need that UTF-8 for a page that is in English? But if we wanted to translate this page and we wanted to put it in Portuguese, then lang would equal PT, and the char set could probably also not be UTF-8. That lang is an attribute, that's what it's called in HTML, and this particular attribute assists screen readers to determine the language of the web page. And the goal of the web is to be inclusive, and so if your company has claims of inclusivity, this is something that you want to take care that you have to avoid some future brand damage, or just add it as a tick box exercise in your release checklist. Now, when you have an HTML page, you need to save it in a hard drive, in a server, so that in that same computer, you'll have a program that will serve web pages when you get some requests. And you'll just sit and listen for when somebody wants to talk to it. And you need to take care when you save the file with the right encoding, because otherwise the contents on it will just display some gibberish. And it's something that throughout the years of my experience, it would have saved me a ton of work and a ton of, well, not losing a lot of time if I actually got a pop-up like this one that would actually tell me that, hey, there's some characters here, in this case, the smiley, not so much smiley faces, that will not actually display. Also, apart from this, there's care that needs to be taken when we use some tools, even from known sources, because they might actually tell us that something is right or wrong, and it's not the case. In this particular scenario, I tested google.com on a W3C tool, and it was telling me that the google.com page was coming back in Portuguese for some reason. And the fact is that it was coming fine in UTF-8. So I also want you to notice that there's a translate equal yes on the first image, on image 1, and that helps most modern browsers translate the web page for you. And some of them don't actually need you to install a plugin. You can do it just by right-clicking the page. However, in some cases, you might actually find that it's not really desirable to have that translation taking place. Now, and you want to set that to no. And the only browser that doesn't seem to respect this is Safari. And I have a fundamental problem with this one, which led me to report a security issue to Apple. But a little bit, I'll get into that in a little bit later. Using the macOS as an example, it allows you to specify the languages that you want, and you can set one as primary and one as secondary. In this particular image, you can see that I have my language set up to English. And when I install applications, if for some reason the application is not available in English, then it will use my next preference, and in this case would be Portuguese. If you're curious why I actually use English and not my native Portuguese, it's just because out of habit of working with different operative systems and different versions of Windows, Linux, Unix, and macOS. And if you ignore my regional settings, if you look further at the bottom, you will notice that I have some settings on particular language that I want to use browsers in. And that works too, and it doesn't actually depend on the languages that are specified for the operative system. That means when I actually open Chrome, Opera, or Safari, I'm going to get them in the languages that I have specified. macOS also allows you to do translations offline, and I use a few. However, when we get to Safari, it always uses online translation. And I also have an objection towards this. So when I was testing the functionality of using the global attribute to translate on web pages to see exactly how browsers would behave, I found some bugs. But most importantly, I got upset when I saw that Safari didn't actually respect that I said translate into no. And I came up with a scenario where somebody is using an intranet web page, and it's labeled as confidential. And they translate that page. And what happens is that that page has to go through the network and to a bucket that is in Amazon owned by Apple. And the preference that I actually have of that not happening was if I actually had it specific as a no, somebody had to go and change the source code to yes, so that no accidental translation would take place. So a part of that, I also thought, well, if this has personal identifiable information or the sensitivity of the file is really big, we would not be very happy to share this with Apple. So I put this to them, but they came back and said, nope, this is not a security issue. Nothing to see here, move along. I disagree. But then again,
just to clarify, so you're basically saying that Apple, when you're browsing Safari and there's a need, detects that there's a, language mismatch within who you are and what you're seeing, the Safari would actually send the text of that page to an Apple server for translation.
No, the user will still have to do it. You will have to ask for the translation. But, okay, you can claim that you did that accidentally. And it's like a defense in that type of thing when you set the translation into no. Yeah. And just by having it there, I would feel way more comfortable. It would be something else that I wouldn't have to put in the procedural that we need to check for this traffic if it's going to the bucket on Apple that goes over there or not.
Yeah, because that page, whatever you're watching, could have all sorts of confidential information, right?
I was thinking that even for not only for the military, but you might be working on your intranet, which is supposed to be kept inside on something that is very sensitive. You're going to launch a new product, something like that, and I'm like, this shouldn't be there. And the fact that all the other browsers actually respect, all of the modern browsers, that's the ones I tested, respect the no. I was like, why are they doing something different here? Although Apple does have differences, as we will see in the next slide, is in other things. This one upset me a bit.
It is a security issue, right? Like, whether there's a control in place. If the behavior is different and data that is exfiltrated, I agree with you, man. It's a security issue. We can argue on the criticality of it, but we should not be able to argue on whether it's an issue or not.
I actually saw that the fines were so expensive towards the respect of GDPR that I put some numbers when I wrote the report to Apple. And guys, I'm saving you this. And I thought I was going to get an incredible bounty and go on vacation to somewhere even more exotic. But they didn't agree with me. So, if and when I have to take care of another company and there is confidential information in an internet, this is something that I'll definitely want to.
You should never publish that as a finding, right? Regardless, and even get a CWE for it, because I think it's a good example of some unintended, side effects of basically of a lot of the stuff we do that we don't have a lot of visibility.
I didn't know that I could do that, to be honest with you. So let's take that offline and we can work on that. That would be very cool.
Yeah.
Very cool. Thanks for that. Let me kick off because I still had a lot of stuff here. So most browsers, including Tor, will allow users to specify your preferred language. Safari is the odd one off. And by setting your language preferences, you're basically agreeing and stating that you want to have those preferences shared with the websites that you're going to navigate. And these images on the left are from Firefox and represent my personal language preferences. And the way that this reads, and you basically have this drop downs that this options that you can move up and down to specify the order of your preferences. I prefer to receive my information in Portuguese from Portugal, but if that is not available, then I would like to get it in Portuguese. If that's not available, I prefer British English, but if not available, give it to me in English. French from France, and if that's not available, I can read French. And Spanish from Spain, but if that's not available, Spanish. And if for some reason the server doesn't have any of those preferences, you can pass to me a page in Chinese that I will not be able to read, or you can send me an error code. And that's pretty much how this preference works. Because Safari didn't actually allow for specifying my preferences, and to avoid people from having to install browsers or browser extensions or installing proxies that might actually share information that you're not thinking that it happens, or sharing your surfing experience with third parties, I thought it would be cool to share a way of living off the land, so to say, or so to speak, and show a way that you can actually specify your language preferences if you're so inclined to do so. So in these images here, you can see that I've opened the developer toolbar, and under sources, I specified a local override. Now, and these images show that I got Amazon.com to return to me in Portuguese, when Safari is actually set to English. Now, curiously enough, you will see that they don't have the entire website available in Portuguese, as this pop-up is in white, it's in English, which undoubtedly states that their default language or their fallback language is in English. But you'll get familiar with the details of the override a bit later in this talk. For now, just rejoice that you can get Safari to respect your language preferences, even when they don't have another way for you to do so. But the reason that Apple actually, I believe, at least from the research, that they actually took that off was because of fingerprinting. And now, according to the latest HTTP specification, browser fingerprinting is a set of techniques for identifying a specific user agent and track that over time, using its set of characteristics. And there are a number of request headers, which we'll look into, that might reveal information to servers, and that will be sufficiently unique to enable that fingerprinting to take place. And one of those headers is the accept language header. So I thought that it would be interesting to see this actually in practice. So what I've done is that I've used a tool called Cover Your Tracks, if the slide will move. Sorry, I don't want to click too far. Oh, there you go.
I can see it.
So I've devised 4 tests using Cover Your Tracks. And I use the four browsers in their latest version and macOS. And in the first one, I used the regular window, and I specified my 4 language preferences I've shared before. The second one, I used the private incognito window, and I kept those as well. And then on the third one, I removed all of the language preferences. And on the fourth, I used again the private window. Now, before you say anything, I am aware that the private window is only supposed to not store information on my website regarding the websites that I've viewed, but I've tried it nonetheless. And if we look at the table, and with the information that we have on the site, according to their website, 33 bits is all that is necessary. 33 bits of identifying information is all that is necessary to uniquely identify us in the world. And the way that the browser characteristics, including the language preferences, are or the amount of identifier information that is available for trackers and for online advertising is very high in Chrome, Firefox, and Opera if I have my language settings specified. Now, the same happens on the private window, but curiously, Opera was giving me a different value. And I went under the hood and I tried to figure out what was going there. And Opera has decided that in their private window, rather than having my 4 language preferences, they reduced that down to 1. So in a way, they actually made it a bit more private, and that explains why it's not longer a unique fingerprint, but a nearly unique, so it gets a better value. And then when I removed all of the language preferences, we can see across all browsers that there is less amount of information available to being unique identified. And then I got curious, and I was like, I got a security tool here installed on my computer. I wonder if they will actually make it a bit better. And I run the tests again. And let's see if the image will pop. There you go. So I had NordVPN. I have no affiliation with it. It's just a tool that I actually had. And I enabled threat protection, and I run the test again. and exactly with the same parameters, exactly the same browsers, and I got better results. Now, I run this around 2 o'clock, 3 o'clock in the morning, and I apologize for the upper results on when I remove the language preferences, because those values are not exactly correct, and I'll explain why. The reason behind that is that I have two screens. I have this one, and the one when I look to the left, I'm looking at my other screen. And when you actually have a browser in a different screen, the characteristics that are shared with that particular tool will be different. So I believe that 1651 would be probably because I somehow had the browser on the left side. Not very scientific and accurate to me. I apologize for that. But nonetheless, the results, we can actually see that the tool improves a little bit the ability that trackers will have to fingerprint us, but that they are still nearly unique. So in summary, if you decide to specify language preferences, you know that your user agent can be uniquely identified. While some online trackers may not know your name, this allows them to have a detailed behavior profile of your online activity, political affiliations, education level, your income brackets, your tastes. And this means also that deleting cookies will not help. And perhaps this is food for thought, and you're probably thinking of testing this tool yourself, and I recommend that you do so if you have the time. But I have a story to share, and I'm going to move from here. So I'll try to keep you entertained. I had two questions that I needed answers to, and I had ruminated about them for the best part of 2 weeks since I had discovered that the book existed. And during that time, I had managed to resist the temptation of getting a copy as I had other priorities and my time and attention it was needed elsewhere. And not to mention that I have several books here that I've already purchased and they are still waiting to be read. But I got to a point that I couldn't resist anymore. I had two questions. And those questions were, if this moves, yeah. Did Tim and Ted really share a meal? And did Ted tell Tim, it sounds funny, all this is just FTP with lipstick. Now, I knew that Tim's parents were both academics and in computer science, and I knew that Tim has a degree in physics. So I was more than 100% convinced that he had to be familiar with Ted's publications. But this was all fresh to me. I hadn't come across this before. And around 1965, if that one will come, there you go. Ted Nelson, Professor Theodore Home Nelson, had written an article or paper, a file structure for the complex, the changing, and the indeterminate, apologies. Now, the paper is incredibly interesting, and it details his vision of a dream file and its design. And while I was reading the paper, it was I would love to know the professor's opinion about Google Docs revision functionality, because for me, while I was reading, it was like, yeah, they have this, yeah, they have this, yeah, they have this. So I don't know if they actually went there and read the paper from the 1960s and achieved all of that or not. I would love to get the professor's opinion. I thought it was really interesting. But in this paper, the professor also coined the term hypertext in the mathematical sense of extension. And you may not be familiar or ever heard of a project called Xanadu that also started in the 1960s by the same professor. But it was a project that addressed similar issues that those that Tim Berners-Lee had to solve in CERN in the 90s. And in a nutshell, both men had the ambition to improve the way that researchers track knowledge. And a lot of it had to do with the way that references function and references between papers on how to link them. And to be honest, I don't really recall if I read that paper first or if I read an interview with the professor where he actually shares that he and Ted had shared, Tim and Ted had shared a meal, and that I was curious to find out if he actually told Tim that he thought that HTTP was only FTP with lipstick. So, you know, that stayed with me for 2 weeks, and then I just got a copy of the book. And the book is Weaving the Web from Professor Tim Berners-Lee. And when I came about the FTP with lipstick, I was like, say what? And I got really intrigued. So I needed to know more. And when I read the book is really easy to read, and it's very interesting. And it gets...
Oh, man, that's an amazing book, man. That brings me
back
to time.
It's pretty cool.
I remember reading that book and like really, really understanding the web and like getting, this is going to be massive, I think.
the description of all the problems that he had, and if you grab Xanadu and you see, when you read the book, it just starts to come all together.
Yeah.
There's bits like they're really human. It tells a human story. There's people that own money to some other people. I don't want to spoil the book to anyone. But the answer towards did they have a lunch? Yes, they did. But what they ate and who paid for it, you'll have to read the book as well. The answer is there. And before talking about the HTTP protocol, there's because this is a story basically to do an introduction to that. There was a very interesting sentence, I thought, that Professor also has in the book, and it's this one. I happened to come along with the time and the right interest and inclination after hypertext and the internet had come of age. The task left to me was to marry them together. And I thought this was very honest, and I really enjoyed it. So when two computers agree that they can talk, they have to find a common way to represent that data so that they can share it. And this is also another sentence from the book from Tim Berners-Lee. And this is where protocols come in. And protocols, a protocol is a set of rules and controls in the way that computers exchange data. And this comes from the Cambridge Dictionary. But Tim Berners-Lee in his book also says that the internet is a network of networks. Its essence, though, is the standardized protocols, the conventions by which computers send data to each other. Now, in the 90s, in the early 90s, but before, so in the early 90s, the internet had already evolved from what was called in the past ARPANET, and that was a network developed by the United States Defense Department, and it was controlled by them in collaboration with some universities. But then other networks started to appear, and those networks didn't speak to each other. So there was the same type of a complexity that we had with US ASCII, or the representation of language or characters in the screen. The same problem started to exist with networks. And this is where the IP range of protocol, or IP protocol suite, comes in, as it will enable the communication between networks that don't actually speak the same language. So IP, the characteristic of IP, which is most interesting, is imagine that you want to visit from your browser example.com. If the route is not always the same, so you'll have to go from your computer to the provider, your internet service provider, and then they will know somehow how to get to example.com. But even when they know that path, it's like when you're driving, there's other roads to get to the same place. And if one of those roads is interrupted, the protocol knows how to find another path to get there. And TCP, on the other hand, is it's a very reliable protocol. If it was humans talking, it would be a bit like this. I would say hi, and you'd say hi back, and I would acknowledge that you'd say hi. So I know that you're listening to me, and then we can communicate. And the difference towards UDP is that in UDP, I'll just say something, and I don't really know if you listen to me or not. And that was what enabled the World Wide Web to come into place. Now, if we look into a better way of actually thinking about this, it's by using the OSI model, the Open System, OSI, I didn't say that correctly, Open Systems Intercommunication Model. And you have 7 different layers. So you have the application layer, you have the presentation, session, transport, network, data, and physical. And this basically means that from the point that you want to transmit some information from your browser, the interface that you're interacting with, and you are asking for example.com, bits have to be converted into different meanings so that they go from all of those until they actually get into zeros and ones and get sent throughout the network. And this is basically used, this table or this model, for coordinating the efforts between systems intercommunications. And it basically describes what needs to happen and which protocols need to exist so you get a packet out through the network. So let's focus in an HTTP request, and it's composed of 3 lines of text. And the first one, it's called a request line. And here you can see the get method, and it's asking for examples.com default resource at port 80, which is implied by the protocol used, HTTP. And he also informs that he would like to communicate with version 1.1 of the protocol. And I'd like to prove that to you. Now, I'm not using a browser here. Oh, wow, it doesn't actually share. Wait, let me stop here. Or does it, then I can't actually see it. Can you see 2 other windows?
Yeah, I can. Yeah, I can see
two terminal windows?
2 text
Cool, cool. Thank you for that. I can't actually see it here for some reason. Cool. All right. So I'm using a tool called curl. I'm not using a browser, but this will function in the browser exactly the same. In one, I'm calling http://example.com. In the other, I'm adding a port and I'm specifying the resource that I want. So this is just to prove that if the first is exactly the same as the first, but by convention, normally we don't put it there. The caveat, though, is that sometimes that default resource is not actually index.html because you can specify in the server a different one. So sometimes it's safer just to call the domain if you're after an home page. Let's read it that. Now, another part that happens behind the scenes, even with curl tool, is what that first request line actually, what happens. So when the browser sees that example.com, it doesn't know its IP because computers don't know in the network, computers are known by IPs. They're not known by name. And the browser will try to see if he already knows the IP address of example.com. And if he doesn't know it, he will ask the operating system, hey, do you know the IP of this particular domain? And the operating system will look in its own cache, and you think about cache as being a temporary storage of information. And then if it doesn't know it, you will have to go into the network and ask somebody that knows it. And that is part of the DNS protocol, which is a bit outside of this talk. But anyway, there's negotiation to get to the IP so that the request can go forward. And the reason that this exists is that it alleviates all the synchronization that needed to exist in our own computer if we needed to know and keep track of all the changes and all the domain names and everything that keeps on changing on the internet. So that responsibility is delegated. Now, I'll probably mention this first. When we ask for, in the example before that I gave, where I actually got Amazon.com in Portuguese, they have their default page in English. So different resources may have exactly the same content, and those are called variants. The reason for that, or better yet, there's a principle that it's actually mentioned in the book by Professor Tim, is that each resource should have its own unique URI. That's a uniform resource identifier. Uniform resource identifier. The name's changed, and he was also not happy about that, so bear with me. And in this case, it's in the example.com /index.html, being that the resource is in the index.html. Now, in principle, as each resource should have its own URL, you don't want to call Amazon.com and expect that URI not to change, because then the principle of uniqueness is violated. And the reason for that is that if you want to be precise into the linking that you have, you want to refer to the resource exactly as is. Another example is, because this doesn't happen only with language, if you can have a page in HTML, but you can also have it in PDF. And those are variants of each other, and they should reference each other, but they should have different URLs as well. And the server should try to accommodate for that. Now, the other two lines here are headers. And let's see if the image changes. And it's not changing. There you go. Cool. So headers are composed of lines, and the line starts with a name, followed by a colon, followed by a field body. In this case, example.com. If we look at the host one, and it has to be terminated with a carriage return or a line feed, but it has to follow some rules, and those rules are actually, you know what, I'm going to end here with this but let me finish this bit. So the names have to follow US ASCII because headers use US ASCII, which is, remember this, 7 bits, and it has to have values between 33 and 126, which allows for some verification of the input is actually correct. And the body of the header, it follows the same, but also allows for space and horizontal tabs, but it can break into multiple lines. And this folding has actually been used for a lot of hacking, not particularly only with the exact language, but it's something that we will see in the second part of this talk, because I'm going to end it here because I already see that we're doing this for 58 minutes. And yeah, that will be this for today, and I'll follow up in the next talk. Thank you for your attention. I got a lot of other slides, guys, so I'm going to stop it here because otherwise it's way too much.
Okay.
Maria. I lost track of time.
So it's 44.
Oh God, but I had 1 hour on my timer here. So if you haven't stopped, I'll continue then.
Yeah, continue for more, yeah.
All right, sorry, let me share then. And wait, how do I do this? Wow, this is pretty slow. Let me just pull that. Oh, bear with me. I'm just trying to get to the same point that I was. Yeah, I was here. Okay. I'm not sure was it still doing this, but let's see. Can you see it? Can you guys see?
I can see it.
Okay, cool. All right, let me move on to the next one. So this is an example of some fields that are sent by Firefox in its latest version in the macOS. And you can see that the browser is sending information to the server. And that it's telling it that it wants to go to a host, in this case, André Ferreira website, and it accepts HTML and text, application in XML, and it has a strong preference around it, which is the Q9 that I'll talk about in a different slide, and then that it prefers AVIF images or WebP. It also is able to understand JZip and deflate BR, and it would prefer to receive the resources in the languages in the order of my preference. And then it identifies its user agent with a big string that it doesn't really represent a user agent because of fingerprinting. In the Mac version, for example, they stopped changing it because they wanted to stop fingerprinting.
So that accept language is the one you say that actually creates quite a unique identifier tracker.
Yeah, as we saw before, if you actually have it as big as mine, that will increase the way that I'm fingerprinting. But the trade-off always here is that I'm going to get exactly what I'm after. So it will be me as a user that should have the freedom to say, I don't really care that you track me, or I care, or only share that with particular websites. Because the problem with the accept language header is that if you have never visited a website before, every single resource, and imagine that there's 150 images on the homepage, all of them are going to get that accept header. But in reality, that doesn't help. Well, it would help if the content negotiation was done for every single image to get a representation in Portuguese. But in most websites, the images are not actually translated. It's mostly the content, the text. So it becomes a bit wasteful. But on the other hand, the fact that it's a proactive negotiation, it saves you from actually having to get a page and then going through the flags or the dropdown and selecting a language. So that it's actually faster. But yeah, as soon as you specify this, you'll be further tracked, or your possibilities of tracking you are superior. And let's zoom into that. So in the slides, we have exactly the same headers, and we can see that the first language that I have, PTPT, is actually called a subtag, and it's composed of languages that are requests for comments that specify what those values are. And there's also IANA registry that keeps track of all of the ones that are registered so that you can actually use. So validation can actually be achieved against that registry. And, let me actually read the slides here. Some recipients okay, so regarding the order of the languages as I have it, you might notice that PT and then PT actually have a quality value of 9, because that's what it means. And that if I had other languages that had that 9, there's some bugs in some have had some bugs in the past where this actually existed and passed and crashed the server. But the composition is pretty much detailed on the specification, and there are requests for comments in all of them. There are some caveats that /private use and grandfather use is not something that I personally, with my experience, have ever seen used, but I have not. The maximum that I had to work with was 16 languages in a single website. I never had more than that, and I didn't work in word processing or, language more intensive type of applications are done work in the operative system level. So those, I'm guessing those would actually be used there. And when you don't actually specify a quality level, so for example, you only say, I want English, then that pretty much means that, yeah, that quality value is 1. And that breaks down to more or less something like this, with the values on the table on the left side being the specific values that I've specified when I actually put them in order in my preferences. Now, some of the advantages of this proactive content negotiation is that it avoids the communication to go back and forth. And the server does not need to describe how it's actually going to look at your preferences and how it's actually going to make the choice. So the fact that I have Portuguese specified does not mean I'm going to get a Portuguese page. If there is one that is in French and English is also not available, they will serve that. How that happens is transparent for the client. It's logic that sits with the server. However, the disadvantage, one of those that I've already mentioned, is that it's a bit wasteful, making it a bit inefficient, and there's risk for privacy, though that fingerprinting that we've discussed, it's a matter of choice. You'll have to decide exactly if that nearly unique fingerprint does not actually mean unique fingerprint, and you're tracked either way, and you rather get, consume content the way that you want to consume. There has been a lot of abuse with the language accept header, and these are some of the cases. There are CVEs that are open, so you can actually send something even bigger than mine. You can specify, there's a limit, but it's not in the specification of 8,000 bytes, if I'm not mistaken, on this total size of the accept header. And in the first versions of HTTP, that used to be sent in as plain text. It became binary from HTTP 2. So that actually meant that anyone on the network, if you have a man in the middle, somebody that is listening and wiretapping your connection, they actually get access to all of those language preferences. But then again, if they are wiretapping you, they pretty much know who you are, because otherwise they wouldn't be wiretapping you. With language preferences, you'll be sharing that. And if you sent in very large ones, that would crash some servers, and the CVEs that if you want to verify it. Then there was a way to craft some packages, some values that it would create a loop on the server. You started thinking, and when I saw this one, I thought it was interesting because the details of the CVE don't actually specify exactly how this happens. But if you look at the way that it is composed, and if you start looking at the string and you want to explode it by, say, the semicolon, and if you set, because we are abusing now the accept language header, and if all the values that you have is semicolons, and the computer is also parsing that, you're basically consuming time. And that slows down the server. And if you send a ton of those, you could pretty much crash the server as well. There was also bugs where if you don't actually send any language, the system would crash. In others that I found very interesting is if you actually specify JavaScript as your accept language value, that will also cause problems in the server. Others that you can also think about. So if I'm requesting a page in Portuguese and there's one in English, and the logic on the server side would be parse that string, grab the piece in English, and grab a file from the folder that is called English. That would allow for path transversal. And I could actually say, get me the etc password file by just specifying that in the HTML, in the accept language header. It's just a way to exploit it. Or you could also include other files and get them displayed to you. And SQL injections that you mentioned before, yeah, they were also available there because now the server side could actually have the languages in a database, and they could do a select web page where equals English, and then it allows for SQL to be abused. Now, I'm very upset with this slide because at this point, I actually wanted to use Stride for it, but I didn't get a chance. And I was actually thinking that I would manage to get to this slide today, hence the part 2. But there's a lot of things that can go wrong. And this is a big list. And I got that one from ChatGPT, to be honest, of all of the things that can go wrong with language header. And to be honest, also during my career, I saw a lot of those, and I had to deal with them and learn from all of that experience. Now, one way that we can protect servers is with a tool like the OWASP Mod Security Core Role Set. And when I had a look under the hood, I actually didn't find in mod security a specific rule set to parse the HTTP accept language. So I reached out to Dr. Christian on Twitter, and he assured me that it follows the standard rules applied for all other headers. So there is protection there. But the caveat is, of course, that WAFs are not application dependent, meaning that you would still be able to craft a particular particular header in a particular way that will pass the web application firewall and cause some damage on the server side. And that's it. Thank you for your attention. I actually managed to pass most of the things. So I cut a lot of slides because I had more slides, and I went to the detail of specifying the differences in HTTP versions, because now we are at version 3, and there are things that are relevant, but I think that we can do this I can do that in a different opportunity at another time.
Yeah, very, very cool. And I think it's definitely one of the areas that is going to, to keep showing up. And it's a good example of, something that, especially the fingerprinting, I thought was really, really interesting. How, and you could see, there's so much now data and there's so many, independent points that, you can see how that can then be used to actually fingerprint specifically the users, right? And how it falls to the radar on some of the detections. It's going to be interesting to see, how more and more you have these anonymization services, which I think are really cool. Very interesting to see how they handle that and how they proxy and they rewrite some of those headers to try to protect you. But then if they don't allow it, then you still are highly traceable.
I got to tell you that there's one extension that you can install in the browser that is really well known and apparently heavily used that doesn't do a good job and actually calls home. I'm not going to name it. And that when I actually came across the local overrides, I never thought of using it that way. I actually thought, okay, this is something that is worth sharing also, because you can do exactly what you were talking about. So you can have the security tool, but you have to trust them, or you can do it yourself. Now, the caveat there is that if you're going to do it yourself, it's going to be a lot of work. So, and it's going to be a lot easier for sure to use a security tool to do it for you. But it's like if you're a power user, you can. You don't have to delegate that and potentially have to trust and have to share. But yeah, it was very interesting to me to also find that information. The changes and the experiments that, and I'll mention it still. So Google, this talk came because Google, I found out that they were doing some work changing the way that this proactive negotiation happens. And we could make it even more efficient. If I actually sent it only a header, right? A head request. If I send a head request with my language preferences and I don't send anything else and I get the head response back, then that negotiation can happen at that level. But I could also make it different. I could send a head request and the server would tell me all the languages that he has available. I lose no privacy and I select one of them. Yep. Now, that can still happen. The content language can come when I get all of the index page, but that index page can have 200, HTTP requests, like images, videos, whatever. And that makes it inefficient. But the privacy of the user would be retained. And I started asking myself, why does that not happen? And we have tools like Google Analytics that, do a lot of tracking to improve the user experience and so that you can improve your products as well online. And when you specify your language preferences, those get available in JavaScript. So if you go into the console and you type, navigator.languages, if I'm not mistaken, you will also get access to all the list of the languages preferences. So that basically will go away. And it's not all about tracking. It's not all about evil. It's also about people being able to improve the, websites, stores, to serve their customers better.
But we already have something that happens a little bit, because if you think about it, you already have the especially for content security, you already have the initial GET request that you can use to get a policy. You already have the first options that actually can give you that. So there's a lot of things that there's places where we can put that, and I agree we'll make it, because at the moment that actually goes with every request. And you might argue that maybe that's not the best case. So cool.
Cash up, that's it.
Exactly, right? Good stuff. All right, thanks for doing the session. Let's definitely do a variation of it. I think I would like to see if we can explore it now to the idea of of adaptive content, which I think is coming to the web, where you start to dynamically create content, and you're going to need to start providing more information about who the user is. It's almost like when we get to the point where we're going to start sending prompts to the server to provide better information, and that has another interesting kind of worms.
Yeah,
we should tread modeling that one. Brilliant, man. Thanks for this.
Cool. Cheers. Thanks for having me.